Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to apply what you have seen in the previous video, which is the idea of f prime x, what it can tell you with respect to whether the interval is increasing or decreasing, and also in terms of identifying the local minimum or maximum. So as you have seen in the previous video, we have what we call the increasing or decreasing test, and we also have the first derivative test. So we are going to apply this what you have seen in the previous video into solving example 4.10 here. Now we have a function, so this is a simple function, polynomial of degree 4, and our first step is to differentiate that function with respect to x. Okay, so that's what we're going to do first. We're going to find what is f prime x. Okay, so f prime x will be 3 is a constant, so just leave it there. Now differentiate x to the power of 4, you will get 4x cubed, minus 4 is a constant, differentiate x cubed, you will get 3x squared, minus 12 is a constant, x squared will be 2x, differentiate a constant, here will be 0. So next we can simplify what we've got on the right hand side here. We have 12x cubed minus 12x squared minus 24x. And it is a good idea to write this expression into factors. So now let's say we factor out 12x. So factor out 12x, this one will become x squared minus x and minus 2. Okay, so next, by inspection, you can see that this one can also be factored into x minus 2 and x plus 1. Okay, so that is the first derivative, and now we are going to find out what are the critical points. So critical points are the points where the graph changes the direction. Okay, so critical points are the points where you can see that the graph changes direction. Okay, now the direction can be related to studying the slope of the tangent line. So if the slope changes from positive to negative, then that is an example of critical point. Similarly, if the slope is positive changing to negative, then this is also the critical point. So that is the idea. And in order to find what is the critical point, you need to set f prime x equals to 0. Okay, so now we're going to set that equals to 0. Therefore, 12x, x minus 2, x plus 1 equals to 0. And based on this, we have 3 scenarios that we can consider. The first one is we can have 12x equals to 0, or x minus 2 equals to 0, or x plus 1 equals to 0. And based on this, we can say that x equals to 0. Therefore, this one is x must be equals to 2. And this one is x must be equals to negative 1. So these are all the critical points. So these are critical points points. Right. Now based on these critical points, you can divide the whole domain of X into proper interval. So that's what we're going to do next. We're going to divide accordingly. So what we have here is just going to create a simple table. So maybe for this one, so this is the interval. The interval will be based on the critical points that you got over here. So for the first one is x less than 0. So the interval of interest will be what happened for x less than 0. Okay. Next, what's the behavior when x is between 0 and 2? Okay. Next, what is the behavior when no, I'm sorry. We have -1. So sorry. I'm going to erase this. Okay, so here we start with the point -1. What happens when x less than -1? Next, what about x between -1 and 0? Okay, that's the second point. Next, what about x between 0 and 2? And finally, we have x greater than 2. Okay, so that's the interval which can be constructed based on the critical points that you got over here. Right, next, what we're going to do is we are going to consider this result that you have. Okay, so the first one is 12x. Okay, the first factor. The second factor is x minus 2. The third factor is x plus 1. And based on that, we would like to determine the behavior of f prime x. And then we can say what happens to our original function fx. Now, what happens if x less than -1? What happens to 12x? Now, when x is less than -1, obviously the sign for this one will be negative. And if x less than -1, the result that you get over here will also be negative. Okay, if x less than -1, the result that you get here is also going to be negative. So negative times negative will be positive. Positive with negative, it will become negative. So the sign for f prime x when x less than -1 is negative. Therefore, in this case, fx will be decreasing on that interval. Okay, next, when x is between 0 and -1, you can pick any value. For example, you can say, what about x equals to -0.5? So when x is -0.5, you can plug into this, and the answer will be negative. When x is, for example, -0.5, you plug into this, you will also get negative sign. X -0.5, you will get positive sign over here. Therefore, negative, negative, positive, positive, positive will be positive. So on this interval, the graph will be increasing. Next, for x between 0 and 2, for example, x1. If x is equal to 1, the sign of this will be positive. X equal to 1, the sign here will be negative. X is 1, the sign is positive. So positive, negative, 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 positive is also negative. And that becomes decreasing. Now, for x greater than 2, you can take any value. Let's say x is 4. 12 times 4, 48 is positive. 4 minus 2 is also positive. 4 plus 1 is also positive. Positive times positive is positive. Positive times positive is positive. So you will get positive altogether for f prime x. So on this interval, fx will be increasing. Okay. Now we are going to determine whether these points given here are local maxima or local minima. Okay, so next what we're going to do is we are going to look at point -1. Okay, this is point -1, where you can see that for x less than -1, okay, if I have this is -1, for x less than that, the sign of this is negative. That means you have something like this. The slope of the tangent line is negative. Next, when x greater than -1, that means x greater than -1, you get something that is positive. So like this. So you can see that this indicates a local minimum. Yep. So this is the local minimum point. So we can say that for x equals to 0, this is the local minimum point. Now, how about for x0? Oh, I'm sorry. Again, I made a mistake. So this is supposed to be here. I'm sorry. So local minimum for -1. Okay. Now, when x is 0, so when x is 0, x less than 0, so I'm going to just sketch it roughly. So x is 0. So when x being less than 0, so x less than 0, f prime x is positive. That means the slope is positive. Less than 0, the slope is positive, which means that it is like this. The slope is positive, so it is like this. Okay, so when x greater than 0, after x greater than 0, the slope is negative, so it's going like this. So therefore you can see that this is a local maximum. So for this one, this is the local maximum. Now how about for x equals to 2? Now for x equals to 2, so when x is less than 2, the sign is negative. When x is greater than 2, the sign is positive. So that means this is also a local minimum. Okay, next, once you have determined that, we can try and sketch it, even though it doesn't ask you to sketch the graph, but we can go on and try to visualize how the graph will look like. So first of all, I think what you need to do is we need to determine for those critical points just now, which is x0, x2 and x -1. What is the value of y for x0? So value of y, or the value of fx. Okay, so the value of fx, when x0, the value of fx, you can see by substituting 0 into this function, you will get that the value will be 5, equals to 5. Okay, so fx will be equals to 5. When x is 2, fx will be -27, and when x -1, fx will be equal to 0. Okay, so you can get all these values by just plugging x0, 2 and 1 into this original function fx. Now what we can do next is we can sketch the graph. Okay, so this could be my vertical axis, and this is the horizontal axis. This is x, this is fx. So the important points should be plotted and labeled. So now we have 0, this could be -1, 1 and 2, so this could be 2. So these are the critical points. Next, this could be 5, this could be 10, 15. So this could be -5, -10, -15, negative, let me just erase that. So this will be -20, -25 maybe, something like that. Next, when x is 0, the value here is 5. When x is 2, the value here is somewhere here, which is -27, somewhere here. When x is -1, it is 0. These are the 3 important points that you have identified. And then next, we have demonstrated that when x less than -1, the interval is decreasing. That means it's going down, decreasing on that interval. Okay, so for x less than -1, we can imagine it looks like this. Maybe it's going down. Next, between -1 and 0, it is increasing. Between -1 to 0, it is increasing. So we can imagine it to be like this, maybe. Okay, it's increasing. And between 0 and 2, it will be decreasing. So it will be decreasing between 0 and 2. So between 0 and 2, it will be decreasing because it's going downwards to make this point over here. So maybe something like this. And then it will increase after 2. Okay, so this is how the graph can be sketched. All right, that's all for now. I think we have done answering example 4.10. Basically, it's asking you to find or to identify the increasing interval and decreasing interval, and then also identify the local minimum and maximum values. All right, that's all. Thank you very much for watching. See you in the next video.